Let's talk about Unit 15 here, detailed drawings. And this, you read through the chapter. It goes a little bit more in depth about different types of detailed drawings than what you're going to see for probably a couple more classes. So don't get freaked out about it. But there is some information here that you need to understand going forward in your classes. Most importantly, and if you think to your 1101 class, yeah, we may do some in 1103 also. We do some of these mono detail drawings. Let's see, next page has an example here of which we do a single drawing of a part, and then there's a table that lists the different sizes, variations, and part numbers. And so we do some of those. And this would be like for a very simple part that is of same size or basic dimensions. But we might make, in this case, we have three different sizes of this threaded rod. Think of, eye bolts, screw hooks, different things like that are a standard shape. Just they come in a variety of sizes. And so we can make one drawing that has all that information in it. So that's a mono detail drawing. Now, next, talking about casting and forging. So a lot of machine parts, some are machined from a blank. So they take a round or a square or a rectangular piece of metal, okay? It could be steel, could be aluminum, whatever. And it goes into a CNC machine and it gets machined to its final shape, okay? But that's expensive. So casting is more economical, but you don't have the, I guess, the strict tolerances that you would have on a machined part. So a lot of parts are cast. And you can tell that they've been cast because some of the surfaces are rough, okay? If you're in the lab, look at some of the clamps that I have there in the lab. I've got like a screw clamp that you would have on a workbench. Okay, a lot of automobile parts. You think about tie rods, some of the parts of the tie rods, the arms for the wheels, and different automotive parts. They have a rough surface to it, and then part of it is machined, so they're cast. And if you read in your technical drawing book, it gives a good description of the casting process. Okay, and so when we draw these things, we have to have basically we have two drawings. We can't have a single drawing, but often there's two drawings in which you have the casting drawing with the dimensions for the mold. So once the part comes out of the mold, that's the size of it. And then you would have the machine drawing where it gets the specific sizes get machined. And here in the example in this book, we have a casting drawing here, which gives the overall sizes of the part when it comes out of the mold. Okay. And then here you have the machine drawing that has the final tolerances. And if you were to look right here, there's a little check mark, looks like a check mark. That's a finish mark or a finish symbol. There's another one right there. And what that is telling us is that those surfaces are going to be machined so that they're nice and flat. And then if you see a number on that finish symbol, that gives you the tolerance, if you will, for that machining. Okay, and it's usually in like micro inches or micro millimeters. Okay, as to the flatness of that part. And then the book here talks about purchase control drawings. Okay, and so. Well, let me back up. And so here is a combination drawing. So you see the the chain line here coming around it, that's the casting dimension. Okay, and then the actual part is what's left. And so you can see it around this side here. And so we can tell by looking at this one drawing that it's going to be a cast part, and this we get the overall size for the mold and then the finished sizes. Okay. Back to purchase part control drawing. So we got a couple of examples here. It's something that we're going to buy from another company. We don't care about all of the dimensions on it. We just care about like the overall dimensions or the color combinations or some kind of information about that. Okay. You read about these other things here. You got some sheet metal drawings that will be covered a lot in the 1109 class. Welding drawings, we do a little bit of that in the 1111 class. We cover welding pretty well there. We don't do circuit drawings or wiring harness drawings in the program. It's pretty simple. If you go to work for a company that does that kind of stuff, then you'll get a lot of experience in teaching on how to do that. Okay, so we're not going to worry too much about it. All right, so let me skip forward here. All right, so here's one of the exercises you're going to do. And here's an example of a finish mark with a tolerance on it. Okay, and you don't have to understand a lot about what those tolerances mean for this class. That will be covered in the 1107 class a lot. Okay, now a little explanation about this drawing. You see these notes right here. So a circle with a letter in it means that's a change from a previous edition of the drawing. Okay, this right here is gauges, meaning that to do quality control and check the depth of this hole, you would use gauge number 5. Okay, for this depth here, we would use gauge number 2 to check that. Okay, and the use of gauges will be covered in the 1107 class when we talk about precision measurements. Okay, so you don't have to worry too much about that. Can't see much of anything there. Okay, some other things I want to talk about and cover in this. Let me go to in the exercises for this week. There's a few more things that you're gonna cover. When it comes to castings, okay, typically you have an 1/8 of an inch additional material on each surface that would be machined. And so we look at this part right here, and it has a total machined height of 1.7 inches. There's a finish mark on the bottom and a finish mark on the top here. So that means there'll be an additional 1/8 of an inch on both sides, because an 1/8 of an inch per finish mark. Okay, and so that's of the casting, and so that gets machined down. So we got a nice overall height of 1.7. Okay. And I put that in Blackboard for you've got a reference there. It's typically 1/8 of an inch, or 3 millimeters, the metric equivalent of that. Okay, clearance holes. We'll talk more about holes and fasteners and things like that in the 1111 class, but you have to understand that like in this case here, these holes, there'll be a flathead screw or a flathead bolt, one of the two, screw, bolt, that will go through there, and it has to be larger, the hole has to be larger than the actual bolt. Okay, so this tells me it's a 0.406 diameter hole. Okay, that is not a typical bolt size. All right, and usually clearance holes are 1/32 of an inch larger than the bolt or the screw or the rivet or whatever's going through it. Okay, so that, for a .406 clearance hole, it's going to be a .375 diameter bolt, okay, or screw that goes through there. And we know that this is going to be a clearance hole because when we look at the drawings right here, there are no thread lines in the elevation or the front view here. The same way for this one, there's no thread lines in those. Let's see, does the next, this one does not show any threaded fasteners either, so those are bolts. But if you remember looking at some of the other drawings, the threaded holes are shown with an additional dashed line. So just remember, a clearance hole will have an additional 1/32 of an inch. Okay, you run into this sometimes, especially if you're dealing with older, maybe non-computer generated drawings. You may even see it on some computer generated drawings in which we have a half view, which like in this example here. This part is symmetrical, top to bottom, left to right, however you want to say it, about this center line. And the symbol that tells us that is at the end of the center line going across there, you've got the two cross marks. That tells me that this part is symmetrical about that line. And especially when we drew things by hand, it was much simpler just to draw half of it. Okay, but with AutoCAD, yeah, we could still do that. It'd be simpler, but if we're using Inventor or some other parametric software, unless you just need to save paper space, on your printed paper, there's not much of a need for half views. But you may still see those, on occasion. Okay, I think that was all of the notes that I wanted to talk about on things for this week. Yeah, that covers everything in my notes. If you've got questions with any of these things, everything else, send me an email or come see us in the lab. Okay.